my machine learning group's final presentation. My name is Aditya Natham, and I worked with Anthony Lee, Gaurav Patel, Ryan Ha, and Tyler Tam. We did a deep literature review in our topics of using machine learning in sports outcome predictions. And this graph just shows a few models and how the paper uses them. And as you can see, like neural networks is at a high number, and then other, and as we go on, there's some more specific models that aren't really covered or as well known. We even consider what models we have to use. We have to think about the data set and how it pertains to the NBA players. And so we did a deep dive and searched through Kaggle, and we saw that there's a basketball NBA statistic group, and there's also an injury statistics. And both of these combined, we could just look at the whole scenario and it would help us predict the wins and losses. And a few of the stats that we saw were like draft combine stats, game info, play-by-play, team details and team history. And we would have to figure out later, which are useful, which are not, which would help us get more accuracy. The goal of this project is to develop a predictive model that accurately forecasts the outcome of NBA matches into wins or losses. The use case is to provide stakeholders such as sports analysts, betting companies, and enthusiasts with reliable predictions to assist in the decision-making process, whether that's be a bet or choosing a side. There's a huge market for this type of analysis as the entertainment industry gets bigger and as the number of sports organizations, fans, and bettors increase. These companies and individuals want more data-driven insights. Teams and coaches can also better prepare for upcoming matches through their training or player selection. And of course, there's a massive economic impact as more people will be inclined to participate in this industry. Data preprocessing is debatably one of the most important parts of any machine learning process. Having good, clean data will allow models to easily swift through and make accurate predictions. So these are a few of the data preprocessing methods we used. One-hot encoding, which converts categorical variables into numbers. Principal component analysis, which reduces the dimensionality of the data by transforming it into a new set of variables. There's also interpolation, which interpolates missing values to complete the data set. A few of the machine learning models we used were linear regression, decision tree, and support vector machines. These are very well-known, common models, and we thought we could just fine-tune these to meet our needs. So linear regression would be used for classification, and in this case, we're trying to predict wins and losses, so it's a perfect use case. Decision tree is non-linear model, which is meant for handling complex relationships with multiple variables. In this case, we're talking about multiple teams, multiple players, individual stats, injuries, and it would be very useful. And lastly, support vector machines, which can be used for classification when datasets have many features, as I just described. And so all these have their unique benefits, and we wanted to test them to see which one would be more fitting for the scenario. One of the first models we tested was logistic regression, which had an accuracy of 62.2%. The model is good at predicting wins, but not at predicting losses. It handles binary classification problems by estimating probabilities for given inputs, points to a particular category. It's effective for sports predictions due to the outcome being a win or loss. And as you can see on the right, it's a confusion matrix with the predictions and the correct accuracies. The model we tested was decision tree, which had a 60.78 accuracy. It analyzes data in various domains and provides interpretable rules, which is good for understanding complex decision-making processes. It can capture underlying patterns that influence game outcomes, and the tree structure allows visualizations of important features and which scales well to large datasets. It is effective for binary outcomes, and the bottom right just shows a confusion matrix, and the top is just a decision tree visualization. The model we tested was support vector machines, which had an accuracy of 61.62%. SVMs also effective for binary classification, and they can deal with high-dimensional datasets, which can analyze many different things like performance, home shootings versus away shootings, etc. SVMs are also suited for team stats and historical performances and provide a strong method for making accurate game predictions. Now, once again, this is a confusion matrix on the right with the predicted and the actuals of the model and the actual data set. unfortunately, we were unable to hit the goal of 65%. Our dataset could not account for all the features and variables such as home court advantage or playoff resting. The games are very luck-based, and we cannot consider external factors such as crowds or even travel fatigue. This performing machine learning algorithm was logistic regression with accuracy of 62.2%. And the worst was support vector machines with accuracy of 60.7%. These are a few ways we showed results. The confusion matrix showed actual versus predicted outcomes as a 2x2 table. The F1 score considers both false positives and false negatives. Precision measures the proportion of true positive predictions in all the positive predictions made by the model. The accuracy measures the proportion of correct predictions out of all the predictions made. Next steps would be to fine-tune logistic regression for higher accuracy. Maybe even to combine certain models together, including SVMs, for better results. Using higher quality datasets with more features would also help our references. And thank you.